Assalamualaikum. My name is Mohamad Afiq bin Azman. My matric number B0919104131. I am from 3B I am under supervision of Dr. Mohamad Taufiq bin Taib, and my research title is Effect of B10 and B100 palm oil biodiesel on performance and exhaust emissions of a diesel engine. This is my online presentation outline that starts from problem statement to objective, then to scope, literature review, methodology, and lastly preliminary findings. For introduction, diesel is one of the primary source of air pollution in the world because it releases high number of carbon monoxide emission and it affects the amount of greenhouse gases that links to the climate change and global warming. The crude oil source collected from nature decrease year by year, so fuel price will be higher and affect nation's economic situation like what happened nowadays. One of the best solutions to solve this problem is by using biodiesel diesel blends fuel in diesel engine. Biodiesel can be produced from plants like palm, and Malaysia has advantage for this source since it is widely used and produced in Malaysia. The various composition of biodiesel blend will produce different outcomes from the engine, and various research have been done to improvise the products time by time. Biodiesel can be produced by using trans-esterification process that will alter its properties to be close as diesel properties to produce performance exactly like diesel fuel.
Different feedstocks used to produce biodiesel contains different numbers on its physicochemical properties. Physicochemical properties consist of acid number, calorific value, cetane number, kinematic viscosity, and flash point. Different compositions of biodiesel will produce different numbers of gas emissions. Compositions means the volume ratio of biodiesel with pure diesel. Different compositions of biodiesel will generate different engine performance from the diesel engine. From these problem statements, the aim of the study is to clarify the exhaust gas emissions and engine performance produced from B10 and B100 palm oil biodiesel diesel blends fuel.
The first objective is to produce biodiesel using trans-esterification process. Second objective, analyze the diesel engine performance of B10 and B100 biodiesel. And last objective, investigate the exhaust emissions of B10 and B100 biodiesel. The scope of this research is biodiesel production using palm oil as feedstock, engine performance test, torque and brake power by using engine dynamometer, and lastly exhaust gas emissions, exhaust gas temperature, carbon monoxide, carbon dioxide, nitrogen oxide, hydrocarbon, and smoke opacity by using gas analyzer.
For literature review, I had simplified the related terms to my research for better understanding. First, biodiesel made from feedstocks that combine with pure diesel. Pure diesel is not one that being sold on market. It can only be obtained from oil and gas companies like Petronas and Shell. Feedstocks can be categorized into 4 generations, which are first, second, third, and fourth generations. First generation feedstock consists of edible oil, such as corn and palm. Second generation feedstocks consist of inedible oil, such as karanja and jatropha. Third generation feedstocks consist of waste, such as waste cooking oil, animal fat, and algae. Fourth generation feedstocks consist of solar energy that being converted to biodiesel, such as photobiological solar biodiesel. Biodiesel can be produced into various compositions such as B10, which means 10% biodiesel combined with 90% pure diesel. The higher the number, the higher the biodiesel volume used, and the lower the pure diesel volume used. Next, trans-esterification process. There are many other processes other than trans-esterification, but only this process possible to produce biodiesel with similar qualities as conventional diesel. It is process of converting triglyceride contained in feedstocks to esters and glycerol by addition of alcohol such as methanol or ethanol, and can be supported by catalysts such as hydroxide to speed up the reaction. After converting process was done, the biodiesel produced will be blended with pure diesel to produce biodiesel diesel fuel. Next, engine performance characteristics. It consists of torque, brake power, brake thermal efficiency, and brake specific fuel consumption. Brake power is the usable power output of the engine. The power of an engine's brake is directly proportional to the torque of the brakes. Brake thermal efficiency is the capacity of the engine to transform the chemical energy of fuel into mechanical energy at the output shaft. Brake specific fuel consumption is the effectiveness of the energy conversion. More effective, less fuel consumed. For other point, different biodiesel production with various compositions produce different engine performance, whether it has increasing or decreasing trends in result. The result is more direct and did not have unstable reading across all parameters. For exhaust emissions, it consists of carbon monoxide, carbon dioxide, nitrogen oxide, hydrocarbon, exhaust gas temperature, and smoke opacity. Different biodiesel production with various compositions produce different engine performance, whether it has increasing or decreasing trends in result. The result also more direct and did not have unstable reading across all parameters. These are some of previous research that used various feedstocks, nanoparticles, and catalysts. Some findings are the addition of nanoparticles to diesel biodiesel blends significantly altered their chemical and physical properties, and higher pentane volume emits better performance. For methodology, the process starts with biodiesel diesel blends production to engine preparation to engine testing and lastly data collection. This is my flow chart for methodology process. For biodiesel diesel blend production, blending process has been used to produce biodiesel diesel blends. It is the last step of trans-esterification process. 1 liter of B10 has been produced by 100 ml palm oil biodiesel and 900 ml pure diesel, that means 10% palm oil biodiesel combined with 90% pure diesel. Both pure diesel and palm oil biodiesel being blended separately by using electromagnetic stirrer until 100 degrees Celsius, then being cooled down to 60 degrees Celsius. Both items being poured in a beaker and being blended again until the temperature reaches 70 degrees Celsius, then being cooled down to room temperature before store it in HDPE container. For engine preparation and testing, single-cylinder fuel injection diesel engine was overhauled to inspect the engine components. The engine was coupled to the dynamometer coupling and gas analyzer sensor was attached to the exhaust. The engine being tested by using conventional diesel first to detect any leakage or damage came from the engine components. If the engine free from any leakage or damage, palm oil biodiesel diesel blend will be tested for its performance and gas emissions on the same engine. For data collection, engine performance data and exhaust emissions data was recorded by Dynamite software. The data was plotted by Excel to study the trend of the data collected from the software. Engine performance consists of torque, brake power and brake-specific fuel consumption. For exhaust emissions, carbon dioxide, carbon monoxide, nitrogen oxide, hydrocarbon, exhaust gas temperature and smoke opacity. For preliminary findings, data from conventional diesel used in single-cylinder fuel injection engine being recorded and evaluated. For first graph, the curve becomes steeper from zero load to the full load because of the piston push regularly that gives a result of better horsepower output, and the engine did not lose power during the combustion process. For second graph, the curve becomes steeper from zero load to full load because of the increasing load. Higher load applied to the engine will push the engine to consume higher fuel during acceleration. This behavior will assist the engine to maintain the load, and this can avoid overload towards the engine. For third graph, the curve becomes steeper from zero load to the middle load and slowly become constant after middle load to full load because of the increasing load. The engine can still accelerate from zero load to middle load because the load applied can be considered as low. But when approaching the full load, the engine cannot produce higher torque and it will become constant along the run. For fourth graph, carbon dioxide emission increase because of the engine load increase. Higher loads consume higher fuel consumption, so higher carbon dioxide will be produced. For fifth graph, carbon monoxide emission increase because of load increase will produce higher incomplete combustion. For sixth graph, nitrogen oxide emissions increase in emission and engine load due to an increase in the amount of fuel consumed by the engine. For seventh graph, hydrocarbon emission increase because the shortage of oxygen produced by the engine's operation, which result in a fuel-rich mixture. For expected result, based on article Effect of Biodiesel on the Performance and Emission Characteristics of Diesel Engines, conventional diesel produce higher torque than pump oil biodiesel, and the torque produced becomes lower when the composition of biodiesel increase. Based on article Performance and Emission Analysis of a Diesel Engine running on pump oil diesel, carbon monoxide emissions of pump oil biodiesel diesel blend will be lower compared to conventional diesel, and brake power of pump oil biodiesel will be lower than conventional diesel. Based on article Performance and Emissions Characteristics of CI engine fuel with pump oil methyl ester blended with diesel fuel, nitrogen oxide emission will increase as engine load increase for all load. Based on article Performance and Exhaust Gas Emission of Biodiesel Fuel with Pump Oil Based Additive in Different Indirect Injection Compression Ignition Engine, brake specific fuel consumption of pump oil biodiesel diesel blend will be lower than conventional diesel, and higher pump oil biodiesel blend require more fuel to provide the same amount of braking power. Based on effect of biodiesel fuels on diesel engine emissions, emission of carbon dioxide also increase as engine load increase due to the higher fuel consumption associated with increased engine load. Based on article Performance and Emission Characteristics of CI engine fuel with pump oil methyl ester blended with diesel fuel, hydrocarbon emission will increase for pump oil biodiesel at all engine loads compared to conventional diesel fuel due to the higher cetane number. Increasing the proportion of biodiesel in biodiesel blends will reduce the hydrocarbon emissions. Based on effect of biodiesel fuels on diesel engine emissions, exhaust gas temperature, pump oil will produce higher exhaust gas temperature compared to conventional diesel.
That's all from me. Thank you.